quantity in the numerator again and quantity in denominator. Our goal today is to get these rational expressions in simplified form. So for example, if we saw 2x over 10x squared, that is a rational expression, but it's not in simplified form. So we would want to divide the numerator and denominator by 2, divide out an x in the numerator and denominator, so we'd be left with 1 over 5x. This would be our simplified ratio, simplified rational expression. If we had 2x minus 1 over, let's say we had it over x minus 3, we couldn't simplify. We could not cancel out. We can't cancel out these x's because there's a plus or minus in between parts or terms. Here's 1 term, 2 terms, 3 terms, 4 terms. Unless all are divisible by the same amount or variable, you can't divide. So I can't cross off those x's in the numerator and denominator. When you simplify rational expressions, you want to see if you can factor or break down first before you cross off. So the expression in the numerator, you can't factor, can't break down, so you're going to put parentheses around that quantity. So you don't on accident cancel out an x, let's say. In the denominator, you want to see if you can factor or break down. Quantity x minus 3 does not. So because these expressions aren't the same on top and bottom, we can't cross off. If we had something like this, we factored and we got this in the numerator and denominator, we could cancel out the quantities x plus 3, and then we'd be left with quantity x minus 1 over quantity x plus 4. So you wouldn't be able to simplify any further. Let's look at some problems. So when are two rational expressions equivalent? We're going to write an expression that's equivalent to this expression. So what we can do is we can simplify or factor in the numerator and denominator. So we're going to factor our numerator and denominator. So up top, we can take out a GCF, right, in the numerator. We can take out a GCF, and we see an x that all three terms in the numerator have in common. So we'll take out an x, and we'd be left with x squared minus 5x minus 24. I'm going to work on the top first, okay? So I'm going to say the top, the numerator. I'll do that in blue, and then I'll simplify the denominator, and then we'll see what cancels. Now I want to see if I can factor this trinomial. Is there a combo that multiplies to a times c, or negative 24, that adds to negative 5? Let's see. 1 and 24. 2 and 12. And I'll throw the negatives in later. I'm just looking at numbers that multiply to 24. 3 and 8. Okay, this looks like I could play around with that and have one of those negatives, so they add to negative 5 and multiply to negative 24. So if they add to negative 5, the 8 has to be negative. Otherwise, if the 3 was negative, it would be positive 5. So we have our factors. X minus 8 times x plus 3. We bring down our GCF. So this is our top factored, okay? Now let's work on the denominator. So we're going to work on the bottom on the denominator. So again, in the denominator, there's a GCF. You always want to take out GCF if you can. X. So we have x squared plus x minus 72. So again, we're looking to see if those are combo. To break down this trinomial, what multiplies to a times c, or negative 72, that adds to 1. Okay, so 1 and 72, 2 and 36, no. Let's see, the numbers have to be close together. How about some combo of 8 and 9? And if they add to positive 1, the 8 needs to be negative. So we'll have x times x minus 8 times quantity x plus 9, and this is the denominator. So now if we go back to the problem, we have x times x minus 8 times x plus 3 in the numerator, and in the denominator we have x times x minus 8 times x plus 9, and in the numerator and denominator we can cross off an x, we can cross off the quantity x minus 8, and then we're left with quantity x plus 3 over x plus 9. I recommend keeping parentheses around, or else you might be tempted to cross off the x's. So you can leave it like this, but what will happen is some people might want to cancel out the x's, or they might want to divide the 3 and 9 by 3. Can't do that. Can't divide by 3 because this term, this term, this term, and this term all need to be divisible by 3, and they aren't all divisible by 3. So when you have plus or minuses in between parts or terms, you need to make sure that all parts or terms are divisible. Let's look at the next one. So for this next one, it says simplify a rational expression. What is the simplified form of this expression? What's the domain for which the identity between the two expressions is valid? So we're going to look at the numerator and we're going to try to factor this. Now there's no GCF. Now we often are used to seeing the x first, right? We are used to seeing x squared minus 4, and we know that it would be x plus 2, x minus 2, right? Square root of x squared, square root of 4. Now this one is written in the opposite order. So square root of 4 is really a, was 2. X squared is really your b. So you would have 2 plus x times 2 minus x. And even though these look similar, they're not the same. So we're going to replace the numerator with 2 plus x in parentheses times 2 minus x. And in the denominator, we're going to factor this trinomial, what multiplies to negative 10 that adds to 3, so we know it's a 5 and a negative 2. So write x plus 5 times the quantity x minus 2. And from there, we want to see if we can cancel something in the numerator and denominator. Now, when I look at these, I see that the x minus 2 looks very close to this one on top, right? Sometimes when they look very, very close, you can try to rewrite one of your expressions by factoring out a negative 1. So let's see, if I took 2 minus x and I divided out a negative 1, right? I would get negative 2 plus x, which is the same if I want to put the x term first. It's the same as the x and the negative 2 and a negative here, right? So this negative times quantity x minus 2 is the same as parentheses 2 minus x. If you distribute this, you get a negative x and you get a positive 2, and these are the same as well, okay? So I'm going to replace the quantity 2 minus x with negative x minus 2. I'm going to replace that. Now in the numerator and denominator, I can cancel out an x minus 2. So up top, I have a negative left, which is negative 1 times quantity 2 plus x over quantity x plus 5. Now that's our simplified rational expression. So it says, what's your simplified? Now it also says, what's the domain for which the identity between the two expressions is valid. What is the domain? Now, when we're stating the domain, we say, we always are going to say all real numbers except what can x be? X cannot be -5 or 2, okay? How I decide what the restrictions are, I set my domain equal to 0 and solve, okay? I set my domain, I set my denominator, equal to 0 and solve. So we factored it. Okay, one sec, Maddie. So, Maddie, go in there. So we factor and set our factors to 0, and that's how we get -5 and 2. So those are restricted values. And the reason we restrict those is because if our x value was -5, or if our x value was 2, our denominator would be 0, and we would have error. So set your denominator equal to 0 and solve, and those are restricted values. So your x values can be everything but -5 and 2. Okay, now this next page. What is the product of 2xy and 3x squared over 4yz? So and means multiply. So we have 2xy over z times 3x squared over 4yz. Okay, man. Okay, so up top we have a 2, a 3, we have 3 x's, right? X squared and x, and then we have a y. In the denominator we have a 4, which we can factor to 2 and 2. We have a y, and we have 2 z's in the denominator. So let's cancel. We can cancel out a 2. We can cancel out a y. We can't cancel out another 3 or 2. We can't cancel out any x's or z's. So our final answer would be up top, 3 times x times x times x. We have 3x to the third power over 2 times z is z squared. So that would be our final answer. So now it says, what's the simplified form of this expression? Oops. Okay. So we see that this is product, right? We're multiplying between all of these fractions, all of these ratios. So simplified form, you don't want to start multiplying, distributing to all terms, or else it's going to become really messy. So what you want to do is look at each fraction and factor the numerator and denominator. So for this first fraction, 5x over x plus 3, in the numerator, I can't factor or break down any further. It's just 5 times x. The denominator, x plus 3, can't factor or break down, but because there's a plus or minus, I'm going to put parentheses around it. It's an expression. Let's look at this next fraction or ratio. In the numerator, we have x squared plus x minus 6. So in the numerator, we have x squared plus x minus 6. So we're going to see if we can factor. What combo multiplies to -6 that adds to 1? So it's 3 and -2. So our numerator, we're going to write as quantity x plus 3 times x minus 2 all over. In our denominator, we have x squared plus 2x plus 1. What multiplies to 1 that adds to 2? 1 and 1. So we'll have x plus 1, and then we're on to our last expression. In the numerator, we can factor out an x, so we'll have x times x plus 1. In our denominator, we can factor out a 5, so 5 times x minus 2. Now that we've fully factored every numerator and denominator, we're going to extend that line, and we're going to cross out common factors. So we have an x plus 3, top and bottom. We have an x minus 2, top and bottom. We have an x plus 1 on top and bottom. We have a 5. Let's see. So it looks like on top I'm left with an x, another x, and in the denominator x plus 1. So our final answer will be x squared on top, right, because x and x. And in the bottom, we just have x plus 1. Now